All right, guys. Here you are. You're in a statistics class. So maybe you signed up for it. Maybe somebody signed you up for it. But before we can start looking at some things related to statistics, I want you to kind of think about, well, what are you actually doing when you're doing statistics? When you hear that word, when you hear the word statistics, what's the first thing that pops into your mind? So to start out with, I want you to just kind of brainstorm. What are some things that pop into your mind when you hear the word statistics? So pause the video and think about that for a second. All right, well, let's think about what might have popped into your head when you think about statistics. Maybe for some of you that are in sports, maybe you're thinking about statistics related to sports. Maybe you're thinking about points per game, yards per rush, goals per game, whatever the case may be, whatever sport you're looking at, there's a number of different statistics that are taken in those sports. Maybe you think about statistics related to the previous election, all kinds of polls taken in the election, percent in favor of that, percent in favor of this candidate, whatever the case may be related to the elections. A lot of different places where you have statistics. Statistics for a class, though. What's it mean to take a statistics class? Well, essentially, a statistics class is going to have these parts to it. If you talk about statistics, it's thinking about collecting, analyzing, and drawing conclusions from data. So essentially, we have three parts to our statistics course. There's the collecting, there's analyzing, there's drawing conclusion from the data that you collect. And a lot of those examples I just gave related to the sports or to the elections, you had to collect that data. You had to then analyze the data. And then finally, and maybe most importantly, you had to draw conclusions from that data. So if someone asks you, okay, what do you do in statistics class? You might include those things. Now, if we did a formal full statistics class, we would really add in a fourth part. So there's really four total parts to a total statistics class. The first part would be asking questions. What I mean by that is we're going to try to clarify the problem and then you're going to ask valid questions about that. So in other words, what are we trying to figure out here? What's the problem that we're trying to look at? And by problem, we don't necessarily mean that there's something wrong. It's just about, okay, well, what do we want to focus on? What do we want to look at? Sports-wise, maybe we collect data to see who's playing well, who's not playing well. What are we doing well as a team? What are we not doing well as a team? If I go back to the election example, we're looking at who or what topic or what concern do people have. And then we're going to ask questions about those things. And that would be where we'd start. Is basically, why are we even collecting data in the first place? And that's related to the problem that we want to look at. Once we've clarified that and we've asked those questions, now we're going to start collecting data. So we need to design and carry out a plan. How are we going to collect this data? What are we going to look at? Are we going to collect the data in person, electronically? How are we going to attack finding out our data problems or collecting this data? All right, we collected our data. We looked at the data, and now we're going to look at analyzing the data. To analyze the data, we maybe try to figure out what are some appropriate graphical and numerical methods to analyze data. How are we going to display our results? If making a certain type of graph helps me decide what kind of trends we have, maybe that's what we're going to look at. Maybe I need to do some computations, things like the mean, things like the median, standard deviation, all things that we'll talk about this semester. Maybe that will be a numerical method that we're going to use. But we've got all this data. What's this data really telling me, and how are we going to analyze it? And then finally, and probably most important, we're going to interpret those results. So essentially, we're going to draw conclusions based on our analysis. I'm going to go back to the sports example, because I coach 2 different sports. Maybe I collected data related to our golf team, and we looked at how many putts that we had in a certain round. Maybe we draw conclusions of our analysis that, okay, we're making too many putts. We have this many average putts per round. That's too many. That's something we need to work on. So that would be a way that we would interpret those results. Now, in our class, because we have a 1 semester class and we're a little bit limited time-wise, we're going to focus most of the time on the analyzing and the interpreting. Not that we won't ever try to clarify the problem, but a lot of times the problem will be given to us. Not that we won't ever collect data, but most of the time the data will be given to us as well. So usually the question and the data will be given to us, and then we have to take the step of analyzing that data, whether it be with a graph or numerical steps, and then finally interpreting those results. All right, well, here's some data to look at. This is some data that Amazon has collected. Here's what I'd like you to think about. Looking at this data here, I want you to think about, well, what's this data represent? And then maybe how would this data be useful for Amazon? So go ahead and pause the video and take a look at this and see if you can answer those 2 questions. Okay, when you look at all this data here, there may have been different things that came to mind as far as what they represent. A lot of times when classes look at this data, they notice, for instance, this value here, and they say, okay, well, maybe that's the price of something that they sold. Or they look at Kansas, and they say, okay, well, Kansas, that's probably a place they shipped things to. That's a state that we have. Boston, maybe that's the same thing there. Boston's a city that maybe we ship to. You've got some of these other things on there. We've got what looks like maybe a code of some sort. Maybe that's the code for a certain product. You've got names on here. So those are maybe people who are customers for Amazon. We got Y's and N's, which probably means yes and no, but yes and no to what? Who knows? So we got a lot of data here, and as we look at some of that data, we can kind of decipher maybe what it's talking about. However, if I were to take this same data and display it like this, well, now all of a sudden that data has a lot more meaning. This data that we had before is really useless without context. By context, what I mean is we now know exactly what it meant when we looked at those different things. Well, some of those things we were probably correct about. The names, you probably figured out the fact that when they had those names, those were customers. The price, you probably were able to identify the price. And so you're probably accurate with that. The couple examples I looked at, though, Kansas and Boston, those weren't places that we shipped to. Those were actually artists. Those were two different bands. You may or may not know those two bands. They're kind of older bands, but so those are actually artists that they're talking about versus someplace that they ship the product to. So the point is, our data that we had is useless unless we have context to put that data into. All right, well, as we look at this data, we're going to try to classify it into a couple different categories. But before we do that, the first thing we want to talk about is when they refer to an individual. An individual is a person, animal, or thing described in a set of data. So a lot of times when you hear individual, you probably think of a person, but statistically an individual could be any of those three things. So whenever we collect data, it doesn't have to be about a person. We're collecting data maybe about an animal or a thing, possibly. Then once we look at that person or animal or thing, we're going to look at what's referred to as a variable. Well, a variable is any attribute that can take on different values for different individuals, which is a fancy way of saying this is what we're going to look at with our individuals. This is what we're going to collect data on. These are the questions maybe that we're going to ask. Well, variables are going to fit into one of two different categories. First type of variable that we could have is what's referred to as a categorical variable. A categorical variable does exactly what the word says there. It's going to place individuals into a category or group. For instance, if I look at someone's gender, that's put into a category. If I look at what year you are in school, a freshman, a sophomore, a junior, a senior, that would be categorical data. Anything that places individuals into a group would be considered categorical. The second type of variable would be what's called a quantitative variable. What a quantitative variable is going to be is, first of all, it's going to be a numerical value. So it has to be a number. But it's going to be a numerical value that operations, by operations I mean addition, subtraction, multiplication, division, any operation can be performed on. So there's really two parts to the quantitative variable. One is it has to be numerical, it has to be a number. However, being a number alone does not make it quantitative. We have to be able to do addition, subtraction, multiplication, division with it. For example, if I think about someone's age, well, age would be numerical, but age also I could perform addition or subtraction on, maybe multiplication. What I mean by that is, if I looked at two ages, I can subtract those two ages and it gives me a value that makes sense. I could look at everybody's age in my classes and I could do the average age, and that would make sense. Versus if I asked everybody what your ID number is, your student ID number, well, that's also numerical, but if I did the average ID number, well, that doesn't really tell me anything. Or if I ask you for your phone number, it's numerical. However, if I added two phone numbers together, those two things would not make sense if I just added them together. So quantitative has to be a number. However, just being a number does not make it quantitative. And that's the caution that I added here. When you look at a data value, just being numerical, that alone does not automatically make it quantitative. So again, quantitative has to be numerical, but being numerical alone does not make it quantitative. So let's go back to the data that we just had from Amazon. And let's see if we can figure out which of the variables are quantitative, which of the values are categorical. Well, to begin with, the people or the places or the things they looked at would be the individuals. So in this case, they were actually people. So the individuals would be the customers. Then we had the place that they shipped it to. So they shipped it to the state or county. Those would be an example of categorical variables because they're in a category. Also, as soon as you see it's not numerical, automatically it's categorical. Price. Well, price obviously is a number. If I looked at the average price, that would make sense. If I subtracted two prices and looked at the difference between the prices, that would make sense. So the prices are examples of quantitative variables. Area code. Well, area code is numerical. However, if I were to add up all the area codes, that doesn't really give me much information. If I were to do the average area code, it doesn't really tell me anything. So area code is actually a categorical variable. Previous CD purchase. Well, right away I see it's not a number, so I know this is categorical. Was it a gift? That was our yes or no question. It's not a number, so it's categorical. The serial number, or the code for the products. It has a mix of numbers and letters, but that would also be categorical because I couldn't do the average, I couldn't add them up or anything like that. And then lastly, the artists, Kansas, Boston, Chicago, those would all be categorical variables. So really for this set of data, the only quantitative variable we had was the price. Now it's really important we know the difference between the two because eventually that's going to tell us how we display them and it's going to tell us how we can analyze that data. Well, because that is so important, I want to make sure that we can identify what type of variables we're looking at in different situations. So this next example talks about student fees. And it says the students at Eastmoor College are concerned about the level of student fees. They took a random sample of 30 colleges and universities throughout the nation and they obtained information about the student fees at these institutions. From this information, they concluded that their student fees are higher than those at most colleges in the nation. All right, so the first thing they asked for is, what are the variables in this one? Well, again, the variables should be what questions were asked, or what questions were asked. Now, I'm going to throw in an extra here, and I'm going to throw in, well, what about the individuals? Well, in this case, the individuals would be the students that they talk to. So the individuals here would be the students. The variable or variables would be, what did they ask those students? Well, they said that they asked these students what their student fees were. So the variables would be the amount for their student fees. If they ask that question, well, what are your student fees? Their answer would be some sort of dollar amount. And the dollar amount would be numerical. And they'd also be quantitative because I could find the average student fee. I could subtract two student fees and see the difference between those, and all that would make sense. So in this case, we only had one variable, and that one variable was quantitative. All right, here's another example. If someone were to look at the quality control for shelf life, and the quality control department at Health Crunch Incorporated, wants to estimate the shelf life of all healthy Crunch granola bars. A random sample of 10 of these bars were tested, I think, and the shelf life was determined. I guess that makes sense. A random sample was tested. Anyhow, from the sample results, the shelf life for all the Healthy Crunch granola bars was estimated. All right, let's go back again and see if we can identify the individuals. Well, the individuals here weren't people, they were things, because they looked at these Healthy Crunch granola bars. The variable, well, what did they collect data about related to those granola bars? Well, they collected data about the shelf life. So when they looked at shelf life would be amount of days, hours, weeks, whatever, which would be a numerical value. And I could find the average shelf life. I could find the difference between one shelf life of granola bar to another, and all that would make sense. So the first thing we're going to focus on is, what are some variables that we might look at? And what category do they fit into? Are they categorical or are they quantitative? And we'll practice that because, again, that'll help us as we start doing our analysis and start doing our displays.